Hi, welcome back. In our earlier lecture, we discussed about the transient circuit can be analyzed by two methods. The first, the classical differential equation approach, and the second, the Laplace transform approach. While we use any approach, we have to understand the behavior of the circuit element during the event of the switching. Because this behavior of circuit element is important to find the initial current as well as voltage of circuit element. So in this lecture, we will be having a discussion about the behavior of circuit element in switching. Actually, switching provides the initial condition. So switching can be done in two time conditions. First, at t tend to 0 means when switching just start at the when time begins. And second, when t tend to infinity, it means switching when steady state occurs. Technically, if you see, the switching can be done at any point of time, whether you are talking about the t tend to 0 or t tend to infinity or at any time t. But as far as concerned about the initial conditions, we usually discuss about the two conditions, t tend to 0 as well as t tend to infinity. Okay, now let me discuss about the different circuit elements. The first is resistance. Now as far as concerned about the resistance, its behavior does not change during the switching. As you know, the inductor and the capacitor are the two elements which are actually energy storing element, and which are actually they actually provide the transient in the switching condition. Resistance does not change during switching, so resistance will remain same. Now second is inductor. So inductor, we will discuss about the inductor. Before we are going to discuss about the inductor, let me understand open circuit and short circuit. While we are talking about the open circuit, and that current is equal to 0 but voltage exists. Okay, that is a usual circuit. While you are talking about the open circuit, I is equal to 0 in open circuit but voltage exists. Second, when you are talking about the short circuit, in that condition voltage is equal to 0 but current through the circuit exists. Okay, now let me discuss about the inductor. So in inductor, the condition is VL equal to L di by dt. So when t tend to 0, V tend to infinity. I repeat, when t tend to 0, here you can say when t tend to 0 or dt tend to 0, V tend to infinity. So hence it will behave like an open circuit. Okay, and you understand Vt tend to infinity means voltage exists in the circuit, and when voltage exists when circuit is open. So in that condition, the inductor behaves as open circuit. Now second condition, when t tend to infinity, so when t tend to infinity, voltage tends to 0. 1 upon infinity means 0. So voltage tends to 0. Hence voltage tends to 0, and voltage is 0 when the circuit is short. Hence the circuit is short. So in that case, in steady state, the inductor behaves as a short circuit. I hope that is clear. When t tend to 0, the inductor behaves as open circuit, and when t tend to infinity, the inductor behaves as short circuit. Now come to the current part. This is also important. While you are talking about the ILT, that is equal to 1 by L minus infinity to t VL dt, or you can, as we discussed earlier, 1 by L हमने इसको दो पार्ट में डिवाइड कर दिया, माइनस इंफिनिटी टू 0 नेगेटिव VL dt प्लस 1 by L 0 नेगेटिव टू t VLT dt. Now as soon as t tend to 0, IL 0 positive is equal to 1 by L minus infinity to 0 negative VLT dt plus 1 by L 0 negative to, at this t we will write 0 positive VLT dt. So this is all about 0 negative to 0 positive, and that will be equal to 0. So this part will be equal to 0. And what is this part? This part is the current just after the switching. This part is just before the switching, and this is the current just after the switching. Hence we can understand that in the inductor, the current just before the switching is equal to the current just after the switching. Okay, so we can say current does not change abruptly during switching in inductor. The current does not change abruptly during switching for inductor. I hope that is clear. Now let me discuss about the capacitance. In capacitance, the normal formula for the current is I equal to C dV by dt, and as we discussed earlier, when t tend to 0, I tend to infinity. And as I tend to infinity means current exists, and current exists means it is a short circuit. Hence, when t tend to 0, the capacitor will behave as a short circuit. When t tend to 0, the capacitor will behave as a short circuit. Okay. But in condition 2, when t tend to infinity, you are talking about a steady state. When t tend to infinity, IL will be equal to 0, and IL 0 is when circuit is opened. Hence, during switching of steady state, capacitor behave as a open circuit. Okay. So for a small recap, in capacitance, in the time of switching when t tend to 0, capacitor behave as short circuit, and when t tend to infinity means steady state, the capacitor behave as a open circuit. Now last, let me discuss about the voltage across the capacitor. As we discussed earlier, VCT is equal to 1 by C minus amplitude T IC dt. We divided this time into two parts, minus amplitude to 0 negative ICT dt plus 1 upon C 0 negative to 0 positive VCT dt, and that should be equal to 0. This integration is equal to 0. As you are talking about 0 to 0, this integration is equal to 0. And what is this? This is all about the initial condition and the voltage across the capacitor when t equal to 0 positive, when t equal to 0 negative. So what we are doing, VC0 positive is equal to VC0 negative. Hence, while you are talking about the capacitor during switching, the voltage does not change abruptly across the capacitor. I repeat, while you are talking about the capacitor, voltage across capacitor does not change abruptly during switching. I hope you understand this.